In the next couple lessons, we're going to divide polynomials. And so we're going to start with dividing by monomials, and then we'll divide by binomials in the next lesson. So we've actually done this before, right? We've divided monomials by monomials before, like number 4. We know how to do this, right? We have m to the 20th divided by m to the 10th. We know that if we take, if we divide like bases, then we can subtract the exponents, right? And so we can do that with number 4. So we have like bases here, and so we can combine those into one base by subtracting 20 minus 10, right, the exponents, and we get 10. All right? Okay, and remember we subtract the top exponent minus the bottom exponent. All right? Now number 8, we have not only like bases, the b's, but we also have 30 and 3, right, just normal numbers. So we kind of compartmentalize these, right? We do the normal number thing first, right? 30 divided by 3, that's just 10, right? We don't subtract or anything, so don't overgeneralize the exponent properties with normal numbers, okay, that we're used to. We just do normal number things with those. Now with the b's, there we can use our exponent properties, right? Because we do have like bases here with the b's, so we can subtract 6 minus 2, and we get 4. And that's it, okay? All right, so number 18, similar situation. Now we have negative 12 divided by negative 2. So once again, we just do a normal numbers do, right? We divide. Negative 12 divided by negative 2. And negative divided by negative is a positive. And 12 divided by 2 is 6, so it would be positive 6, right? Then we deal with the z's. So those are like bases. So z to the 10th divided by z to the 4th, we subtract the exponents. So 10 minus 4 is 6, right? And then we can deal with the y's. We have y squared divided by y squared, which is y to the 0, okay? And we know anything to the 0 power is, that's right, 1, so we can just cancel it out, right? So you can just leave it out. You don't necessarily have to write that there, but just to show you, the mental math at least, or the work, we can do that. Another way to think of it is anything divided by itself is 1, right? So you can just cancel it out here too, right? Y squared divided by y squared, they just cancel each other out and go away, all right? So notice we're not writing the invisible 1 there, right? We can just leave it out. All right. So number 12 and 64 here, I wanted to include those because here we have division written in a different way, right? So what I like to do, you could still take it from there and go to the answer, but what I like to do is write it like this because it's just, you can see everything stacked and lined up. So to me, it just kind of visually sets it up for me to where I can see, oh yeah, the negative 6 divided by negative 3, those go together, and negative 6 divided by negative 3 is positive 2. Then I can see that the y's are lined up there. So y to the 10th divided by y to the 5th, we subtract 10 minus 5 and we get 5. So there's our answer there. All right. And then number 64, we can do the same thing. Now you could also, once again, you could do, you could just take it, and instead of stacking it, you could do negative 9 divided by 3, and you get negative 3, right? Then you can do y to the 7th divided by y to the 3rd, and you could subtract the exponent. 7 minus 3 is 4, right? And then you could do the z's. Z to the 11th divided by z to the 4th. So we subtract 11 minus 4, and we get 7, right? Okay, so you don't necessarily have to stack them. If whatever works for you, definitely welcome to show your work either way. And really on these, you don't have to show any work, right? You can go straight from the question to the answer, okay? So for me, I like drawing the underlines and, doing this kind of thing to kind of show myself what the like bases are and things like that and the like terms, but you don't necessarily have to do that for full credit.